Imagine a creature weighing less than half a kilogram, with a heartbeat 10 times faster than a human's, yet capable of flying non-stop for 8 consecutive days, crossing more than 11,000 kilometers of open ocean without losing its way. That creature is the bar-tailed godwit, a small migratory bird traveling from Alaska to New Zealand. No maps, no GPS, no refueling stations. Only one guiding system exists: light and magnetism. While humans rely on dozens of satellites to determine position, this bird reads the Earth directly through its own eyes. The question is, how can a brain smaller than a walnut employ quantum mechanics to navigate with latitudinal precision? The answer lies within its retina, where nature has installed a quantum magnetometer so precise that modern laboratories still struggle to replicate. For humans, the sun is merely a source of light. For migratory birds, it is an absolute frame of reference. Each day, the sun's position shifts slightly across the sky, a change that should theoretically push them thousands of kilometers off course. Yet it does not. Inside, a bird's brain operates a biological clock, the circadian clock calibrated to the minute through oscillations of the PER, TIM, and CRY genes. These genes function like the gears of a clock, generating the 2-4-hour rhythm of life. As the sun rises higher, the retina records light intensity and sends signals to the suprachiasmatic nucleus, where internal time is corrected to eliminate error. This interaction allows birds to determine where the sun sits in the day and calculate north-south direction without fixed landmarks. If the sun moves, their clock moves with it. In other words, they do not simply see the sun, they perceive the sun's time. But what happens when night falls? In the 1950s, at Goethe University, Frankfurt, scientists placed indigo buntings inside a planetarium simulating the night sky. When researchers rotated the artificial stars around a point different from the true celestial pole, the birds immediately flew in the wrong direction. When the stars rotated around the correct axis, their navigation became accurate again. This experiment revealed that birds memorize the rotational center of the sky, not individual stars. They grasp the geometry of the cosmos that Earth rotates, and that north is an abstract point defined by the collective motion of all stars. Their map contains no X and Y coordinates. It is a map of rotational angles. In this spinning universe, each star becomes a directional vector. By integrating hundreds of such vectors, birds construct a three-dimensional coordinate system surrounding Earth. This is not merely instinctive astronomy, it is spatial geometry encoded in DNA. In 2021, biochemists at Lund University published a discovery that stunned the scientific community. Migratory birds' retinas contain a protein called cryptochrome fear. When blue light strikes this molecule, it triggers a quantum reaction, creating two entangled electrons within a radical pair system. These electrons possess opposite spins, yet their interaction is extraordinarily sensitive to Earth's magnetic field, about 50 microtesla, millions of times weaker than a refrigerator magnet. A slight change in magnetic direction alters spin probability, which in turn modifies electrical signals within visual cells. In other words, birds may literally see magnetic fields as patterns of light overlaying the real world. This represents one of the rare instances where quantum mechanics, often confined to laboratory conditions, operates reliably within a living biological system. The bird's retina functions as a self-repairing quantum sensor, where entangled states persist long enough to provide navigational information. While modern engineers still struggle to prevent qubits from decohering, nature quietly solved that problem tens of millions of years ago. Imagine yourself as a bird flying above the Pacific Ocean. No landmarks, no radio signals, only wind, clouds, and water. Yet through your eyes, the world is not empty, it is layered with invisible data. Bands of shifting light align with magnetic direction, like a heads-up display inside a jet cockpit. Every subtle change in heading tilts that internal map, much like a GPS warning when you drift off course. This is how birds navigate not by intuition alone, but through a form of natural augmented vision. Their sense of direction is not a separate sense, but an overlay of multiple systems: time, light, and magnetism combined into a single visual image. A bird does not merely know it is flying south, it sees south. Humans once believed we were the first to bend the laws of physics into technology, but nature arrived there long before us. A small bird does not understand quantum entanglement as a concept, yet it uses it to survive. No laboratories, no equations, only natural selection, acting as the greatest engineer. From circadian clocks synchronized with the sun, to stellar maps based on cosmic rotation, to quantum sensors embedded in the retina. Everything demonstrates that life does not merely obey physical laws, it exploits them. When we look up at the sky and watch flocks draw perfect trajectories across the horizon, remember, it is not just instinct at work. It is quantum physics alive in motion, a symphony of light, magnetism, and time. And perhaps, within every wing beat, nature is reminding us that mastery of the universe does not require full understanding, only the ability to live in harmony with it.